Hey guys, welcome back. In today's video, we'll be talking about the question that is currently being asked by Google for their online assessments. So we're going to take a look at this question right here, maximum level sum of a binary tree. And that's the LeetCode problem 1161. The question is, given the root of a binary tree, the level of its root is 1 and the level of its children is 2 and so on. Okay. Return the smallest level x such that sum of all the values of the nodes at level x is maximal. Alright, cool. So, for example, they've given us this graph right here, 1, 7, 0, and 7 and negative 8. So what they're saying by root, level of its root is 1 is that this right here is a level 1, and then 7 and 0, those are the children of that, which will be level 2, and then 7 and negative 8, which will be level 3, and if there are children of 0, that will also be part of level 3. Right here. So what we need to do is we need to sum up all the levels right there. So 1, 7 plus 0 is 7, 7 minus 8 is minus 1, and we return the level with the maximum sum, which is level 2 in this instance, because 7 plus 0 is 7, 7 minus 8 is negative 1. Cool. Alright, let's jump into the whiteboard to understand how we're gonna solve this problem. Alright, so we can solve this problem with the two different approaches. The first one being the depth first search, and another one being the breadth first search. So let's see how can we tackle this with using the depth first search. In the DFS, we're gonna start at the root node. So, and we're gonna use a recursion to solve this problem. So we're gonna look at the root node right there. We're gonna also pass in the level information, which is 1, and we're also gonna need some sort of list right there that's gonna keep track of the sum that we've seen so far at that level. So 1 level is 1, and we're gonna put 1 and 2 and 3 here, and we're gonna put 1 in that level. Now we're gonna recur this to its left side first, and we're gonna do 7, and then we're gonna pass in the level plus 1, which is 2. So in the level 2 we can put 7 in there. There's nothing there. We're gonna recurse one more time, and we're gonna pass 7 and 3 here. So in the level 3 we're gonna put 7 here, right? And then there is no more left side to it, so we don't need to do anything. There is no more right side to it, we don't really need to do anything, right? And now we come back to this one. Now we're gonna look at the right side. There is a node there which is negative 8, and it's also occurs at level 3 because we're just gonna pass the level plus 1, negative 8. So we're gonna add a negative 8 in here, which is gonna give us negative 1 as a level 3, right? This is all gonna happen within that array. I'm just drawing another box right here for the updated values. And then we go back up to the parent, we go to its right child, which is 0, and that's the level is going to be 1 plus 1 is 2, and the value is 0, so we add 0 to the level 2, which is not going to change anything, so 7 stays the 1. 7 stays the 7. And we're going to just put the 1 in there because there's nothing else to be done anymore. And that we just literally just loop over the list right here, find out the highest value, and we look at the index of that, and we return 1 plus on top of that index. In the breadth first search, we can use a queue. So we're gonna initialize a queue with the root value in it, and essentially we're gonna go through the queue, and we're gonna process the queue. We're gonna get the sum at that queue, it's gonna be 1, and while we are going through the queue and emptying everything out of the queue, we want to have another queue that's going to keep track of its children's. So while we're processing this queue, we saw 7 and 0 as the children of 1, and we're gonna assign, once we're done processing this entire queue and it's emptied out, we're gonna assign this new queue to the original queue. So now the queue became 7 and 0. So now we're going to process this entire queue. We're going to sum them up. So 7 plus 0, that's going to give us 7. And while we're processing that, we're going to be looking at the children. So if they're not null, we're going to keep track of that. So 7, while we're processing 7, we're going to have 7 and negative 8. And then when we are processing 0, there is no more children. So we don't really need to add anything. So that's gonna become over another queue. 7 and negative 8. And while we're processing that, we're gonna keep track of their children, plus that we're gonna add them. So 7, we have no children. Negative 8, we have no children. And we added them, we got negative 1. So the sum of that level would be negative 1. And negative 1 is the one that, so we're also gonna keep track of which one is the highest one that we've seen so far, along with the level information. So we know that 1 was the highest when we just added it, with the level being the 1, and 7 was also another higher than the one we've seen. So 7, and we and 7 was the total, and the level was 2. So we update that to be 7 and 2. Now we saw negative 1 at level 3. We don't really care about it because we have seen something that's higher than that. So we just entirely keep updating our running values. And in this instance, we're gonna use BFS to code up the problem. So let's just get into the coding. All right, I already added the code here, so we can save some time. So first, the base case, when the root is null, we just return 0. I don't know if they didn't specify any case, so, and they always say that, well, they don't say anything about it, so I'm just gonna return 0 at that, in that case. Otherwise, like we talked about, we're gonna have a queue. We're gonna enqueue the root node into it, and like we discussed, we need to keep track of the final sum, or the sum that we've seen so far, the highest sum, and the level of that highest sum will be the 1, because that's the root node's level. It just told us that, right? And we're also going to keep track of which level we are on, and it's going to make sense in a minute right here. So let's go through this while loop. While the queue is not empty, we're going to do this entire block right here. We're going to also have another queue, and that another queue is the one that we keep track of the children's of this current queue that we are processing. And we're also going to be keeping track of the sum while we are processing that queue, right, at that level. So in this instance, we're going to be processing 1, and there's only one item in here. So when we say dequeue the node, it's going to give us 1. Level sum, current level sum is 1. And does it have a left child? Yes. So there is a 7 right there. We're gonna add it into another queue. And does it have a right child? Yes, there is 0. So we're gonna add it into another queue. And there is nothing more to be done since there was only one element in it. So we're done with that. Now we're gonna check if the final sum is less than the level sum. And final sum, we know it's 1. And the level sum, we just counted, that was only 1, so that's false, so we skip. And then now the next run is going to be on the another queue, right? So we assign the queue equal another queue, and we increment the level as well. All right, so now we're looking at this level right here. While the queue is greater than 0, we dequeue it, we get 7, we added it to our level sum. Is left something and the right something. Yes, there is something in both of them for the node being 7. So we're gonna add a 7 and negative 8 to over another queue right there, and then there is a 0. We're gonna pop that, add it to our level sum, which doesn't really change. It's still 7. Does it have a left? No. Does it have right? No. So we're done. And now we come to this part of final sum, previous level sum, I should call it, which was, or not previous, it's the highest one that we've seen so far. So highest one we've seen so far is 1. Is 1 less than 7? Yes, it is. So we're gonna update our final sum to be 7, and the highest sum level is the level we're on. And we just keep following the same process. Now hopefully that makes sense, guys. Let's try to submit this code. There you go. So hopefully that makes sense. If you have another question that you want me to discuss on my channel, please do put it in the comment section. Otherwise, please like and subscribe to my channel. It really helps me out a lot. Well, see you next time. Bye.